Hi everyone, it's Scott from Maths Logos, and in this lesson we're going to look at the highest common factor of numbers. So let's jump into our first example. Use the diagram below to find the highest common factor of 48 and 32. So this diagram is what we call a Venn diagram, and what we have on the left circle is all the factors of 48. That's everything in the left circle. And then on the right circle we have everything that's a factor of 32. And if you notice, there's this overlap in the middle of our Venn diagram. And these are factors which are factors of 48 and of 32. So we want to use this to find the highest common factor. So these are our common factors in the overlap. The highest common factor would be 16. I'll say the highest common factor is 16. Pause the video, give the question on the right a go, and then your answer will be on screen momentarily. Okay, you should have got an answer of 15. The next example says, find the highest common factor of 16 and 24. A factor is a number that divides into our number, leaving no remainder. And all of our factors come in what we call factor pairs. So to find our factor pairs, I want to think what numbers multiply together to give me 16. So the first pair will always be 1 and the number itself. So 1 times 16. Then we have 2 multiplied by 8 and 4 multiplied by 4. So the factors of 16, in other words, the numbers that divide into 16 with no remainder, are 1, 2, 4, 8, and 16. Then we'll look at the factors of 24. So we have 1 and 24. Remember, 1 and the number itself will always be factors. We have 2 and 12, 3 and 8, and 4 and 6. And then we can list on our factor pairs. So 1, 2, 3, 4, and 6, 8, 12, 24. Those are our factors of 24. Now in this case, we want to find the highest common factor. So we want to look at both lists. Common factors, so 1 is a common factor, 2 is a common factor, and 4 is a common factor. But their highest common factor is 8. The highest common factor is 8. In other words, it's the largest number that divides into both 16 and 24 without leaving a remainder. Our next example says, find the highest common factor of 20, 35, and 40. So I'll start by listing out the factors of 20. We got 1 and 20, 2 and 10, 4 and 5. And I'll list out the factors of 35. We have 1 and 35, and 5 and 7. And lastly, 40. We have 1 and 40, 2 and 20, 4 and 10, 5 and 8. Looking for the highest common factor, I can see that they've got a common factor of 1. They always will, all numbers will. But the highest common factor that they all share is 5. So I'll say my highest common factor is 5. Pause the video and give these two a go, and then your answers will be on screen in a second. Okay, here are your answers. So for the first one, you should have got a highest common factor of 9. And for the second, your highest common factor was 6. If you're using our lesson booklets, now complete exercises 1 and 2. All right, our next example says, given that 210 is equal to 2 multiplied by 3 multiplied by 5 multiplied by 7, and 858 is equal to 2 multiplied by 3 multiplied by 11 multiplied by 13, find the highest common factor of 210 and 858. So both of these numbers are in what's called prime factorized form. They're split into their prime factors. And what we want to do to find the highest common factor is to identify the prime factors that they share in common. So if you notice, they both share a factor of 2 and they both share a factor of 3. And we can use their prime factors to construct our highest common factor. If we know they both share a factor of 2 and a factor of 3, it means that they actually both share a factor of 6. So our highest common factor is going to be the product of the prime factors they have in common. So the highest common factor in this case is 6. Pause the video, give this question a go, and then your answer will be on screen in a second. There's your answer. Your highest common factor was 5 multiplied by 11, which is 55. Okay, let's look at a slightly harder example. Given that 3,780 is equal to 2 squared multiplied by 3 cubed multiplied by 5 multiplied by 7, and 900 is 2 squared multiplied by 3 squared multiplied by 5 squared, find the highest common factor of 3,780 and 900. So what I want to do is I want to go through each of their prime factorized versions, and I want to circle any prime factors that they have in common. So if we notice the 2 squared term, they have that in common. So I can say the highest common factor is going to be 2 squared. And I want to multiply all of the prime factors that they have in common. Now, if I look at the next number, which is 3, they share a 3 squared term. Okay, this has more than 3 squared. It has 3 cubed, but it has at least 3 squared. So we want to use what they both have in common. They both don't have 3 cubed, but they do both have 3 squared. So I'll write that down. Now I look at the 5s. They both have 5s. But they only have 1 in common. I'm going to write down just one of them. And then the 7, they both do not have a 7, so that's not a common factor. I'm not going to add that to my list. I can say that my highest common factor is 2 squared, which is 4, multiplied by 3 squared, which is 9, multiplied by 5. My highest common factor is 4 times 9, which is 45, multiplied by 5. And my highest common factor is 225. Pause the video and give this question a go. Let's go through it. Given that 28,350 is 2 multiplied by 3 to the 4, multiplied by 5 squared, multiplied by 7, and 882 is 2 multiplied by 3 squared, multiplied by 7 squared, find the highest common factor of the two numbers. So we'll go through each list and we'll pick out what they have in common. So they both have a factor of 2. Then we'll look at the 3's. They have a 3 squared in common. This has more than a 3 squared, but the one that they have in common is the 3 squared. This number has 5 squared, but this number doesn't have any 5s, so we can't say that 5 is a common factor. And they both have 1 7 in common. So my highest common factor is going to be this. I can say the highest common factor is 2 multiplied by 3 squared. Well, 3 squared is 9, so we can write 2 multiplied by 9, multiplied by 7. And then I'll do 2 multiplied by 9 to give me 18 and multiply that by 7. And 18 multiplied by 7 is like doing 10 multiplied by 7 and then adding on 8 multiplied by 7. So we can say we can do 10 times 7, which is 70, and then add on 8 sevens, which is 56. And then if we add those together, we get an answer of 126. If you're using our lesson booklets, now complete exercise 3. Okay, let's look at our next example, which is a worded exam style question. A rectangular floor measures 240 centimeters, so that would be 2.4 meters, by the way, and 300 centimeters, which would be 3 meters. James wants to cover the entire floor using identical square tiles. And what that means is they're all going to have the same side lengths because it's a square. Assume he will use a whole number of tiles with no cutting and no gaps in between them. Obviously, that isn't a real life situation because in real life, you would probably cut the tiles and you would leave little gaps in between them. The question is, what is the largest possible size of each tile? And the second question is, how many tiles are needed to cover the floor? Let's look at this first one. What's the largest possible size of each tile? And this diagram off to the right is going to help us. This is our rectangular kitchen floor. And really what I want to answer is, what's the largest number that can divide 240 without a remainder, but also divide 300 without a remainder? So really I'm asking, what's the highest common factor of these two numbers? In order to do the highest common factor of 240 and 300, I'm actually going to look at the highest common factor of 24 and 30, and then scale it up appropriately. So my factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. And the factors of 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6. If you notice, the highest common factor in both lists is 6. What that means is the highest common factor of 24 and 30 is 6. The highest common factor of 240 centimeters and 300 centimeters is 60 centimeters. What that means is if I make each tile 60 centimeters by 60 centimeters, I can divide it into that side and into that side with no remainder. So what's the largest size of each tile? Well, it would be a 60 centimeter by 60 centimeter tile. And the second question, how many tiles are needed to cover the floor? Well, what I want to do is I want to say, okay, how many 60s go into this width of the floor and how many 60s go into the length of the floor? I'll take 240 centimeters, that's my width, and I'll divide it by my tiles, which are, each of them are 60 centimeters. And 240 divided by 60 is like doing 24 divided by 6. So my answer is 4 tiles would fit into 240 centimeters. And then we'll look at the length over here, which is the 300. And we'll take our 300 and we'll also divide that by 60. So how many tiles will fit into the length? Well, 300 divided by 60 is like doing 30 divided by 6. So my answer is 5 tiles. And if you imagine we've got a situation like this where we've got 5 tiles along here, 3, 4, and 5. And then we have 4 tiles up like this, 3 and 4. So it's a 4 by 5. And then obviously this would all be filled in with tiles as well. We can say the total tiles is equal to 4 by 5, which is 20. Pause the video and give this worded question a go. All right, let's run through it. 120 apples and 300 oranges are to be split into identical boxes so that each box contains the same number of apples and the same number of oranges. The number of boxes is as large as possible and no fruit is left over. How many boxes are needed? Essentially, we're asking the question, what's the largest number of boxes that I can split 120 into and 300 into to get the greatest number of groups, so to speak? Really, we're asking what's the highest common factor of these two numbers. So let's look at the factors of 12, and we'll look at the factors of 30. The factors of 12 are 1 and 12, 2 and 6, 3 and 4. And the factors of 30 are 1 and 30, 2 and 15, 3 and 10, and 5 and 6. You can see the highest common factor is 6. So the highest common factor of 120 and 300 is 60. The highest common factor is 60. What that means is I can split the 120 apples into 60 boxes, and I can split the 300 oranges into 60 boxes as well. So how many boxes are needed? We could think of boxes as groups here, really. And so the answer is 60. And we'll write that, we'll say 60 boxes are needed. And that's my answer to the first bit. The second question says, how many pieces of fruit are in each box? Well, if we're dividing into 60 boxes, if I take my 120 apples and I divide them into 60 boxes, there would be 2 apples in each box. And I'll do the same thing with my oranges. I'll take my 300 oranges and I'll divide them into 60 boxes. And 300 divided by 60 is like doing 30 divided by 6. So there are going to be 5 oranges in each box. And the question is, how many pieces of fruit are in each box? Well, there's going to be 2 apples and 5 oranges. There's going to be 7 pieces of fruit in each box. And what I can do is I can quickly check my answer. I can add up my total for my apples and my oranges. So 120 add 300, and that gives me 420. That's the total number of pieces of fruit. And if I divide that 420 by 7 pieces in each box, it should give me the number of boxes. So off to the side, I'll do that. 420 divided by 7. Well, 7 goes into 42 6 times, 7 goes into 0 0 times. So 420 divided by 7 is indeed 60. All right, let's look at one more example. The lowest common multiple, LCM, of 140 and 210 is 420. Find the highest common factor of 140 and 210. We're going to use the fact we know the two numbers, we know the lowest common multiple to find the highest common factor. And we've got a nice little formula that we can remember, and it's this: the highest common factor multiplied by the lowest common multiple is equal to the product of the two numbers. And we want to find our highest common factor because that's what it's asked us, is find the highest common factor. And it's given us the lowest common multiple. It said the lowest common multiple is 420. So we can substitute that in to our formula. We know the lowest common multiple. And the product of the two numbers, well, the two numbers are 140 and 210. So the product means we multiply those numbers together. And we get this formula here. The highest common factor multiplied by the lowest common multiple is equal to the product of these two numbers. And we can rearrange this for our highest common factor. So the highest common factor is going to be 140 multiplied by 210 and divided by 420. And what I'll do is I'll go ahead and type that in my calculator, and it gives me an answer of 70. Pause the video and give this last question a go. Let's run through this one. The lowest common multiple of two numbers is 1890, and their highest common factor is 45. One of the numbers is 135. Find the other number. We're going to say let x be equal to the other number. And then we're going to write out our formula like we had last time. So give me a second to do that. So the highest common factor multiplied by the lowest common multiple is the product of our two numbers. And let's just go through our question and see what we've been given. We've been told the lowest common multiple of the two numbers is 1890. I'll put that in. And on my next line, it says, and their highest common factor is 45. So I've been given their highest common factor. One of the numbers is 135. I know I'd be putting 135 on this side. And then we've said that the other number is x. Up here, we said let x equal the other number. So I would be multiplying by x like that. And the last thing we have to do is find the other number. So all I'm going to do is I'm going to divide each side by 135. And that's going to give me x, which is our other number. I'll do 45 multiplied by 1890. I'll divide that by 135. And that gives me my answer. And I'll type that in my calculator. And that comes out as an answer of 630. If you're using our lesson booklets, you can now complete exercises 4 and 5. Thank you for watching this video, and please consider subscribing to the channel and dropping a like to this video. Thank you.